Welcome to the Calculus, a collection of micro lectures, video lessons, and sample exercises. Let's compute the antiderivative of this rational function. Let's not forget that there are also special cases for rational function, but this time we are introducing them here because we can use the previously discussed rules to solve for the antiderivative of this given function. We have here the integral of 1 over x cubed plus 3 over x squared minus 5 with respect to x. Yes, this is an example of rational function because when you see that first two terms, when you look at the first two terms, we have a variable in the denominator. And of course, if you would like to combine them into one expression, you'll be looking for LCD, which is x cubed and applicable for all the terms. Now, as mentioned, there are special cases for rational functions. That is when we have the exponent, because let's say if we're going to use here the sum and difference rule, you can separate them into this matter. 1 over x cubed dx, then you have plus the integral of 3 over x squared dx minus the integral of 5 dx. For the first two terms, when you're going to apply the law of negative exponent, when we say move up the entire term, the positive exponent will become negative. And you would see here, this is equivalent to x to the power of negative 3 dx. You have here plus the integral of 3 x to the power of negative 2 dx, and of course we still have minus 5 dx here. For the first two terms, as mentioned, we can see that the exponents are not negative 1. Hence, we can use here the power rule, x to the power of n dx, where your n is not equal to negative 1. Okay, because if it is negative 1, then we cannot use the power rule. We have other rule for that. That's a special case for rational function. And at the same time, if our denominators here are binomial or trinomial, no longer monomial, we're also going to use another form of the rule. Okay, so that is only applicable here, or the use of the power rule is only applicable because the denominators are actually monomial in nature, and if we're going to apply the law of negative exponent, their exponents n is not equal to negative 1. Again, this is equivalent to x to the power of n plus 1 over n plus 1 plus certain c. Okay, so previously, as discussed, we can now use the next few rules here, speaking for these two terms as we apply the constant multiple rule. So you have here the integral of x to the power of negative 3 dx plus, move out your 3, x to the power of negative 2 dx minus 5 integral of dx. We're doing this here step by step for us to be able to understand each concept, but if you can actually attack this at once, then you may try to do that on your own. Now, after using the constant multiple rule, let's now use this rule here. But of course, as we apply that later on, we're only going to write 1c because it also encompasses all the arbitrary constants that will actually come out from this term, and that term. Regardless of, there are also some constant multiples there. So we will have plus c later on as previously discussed as well. So since for the first two terms, your n is equal to negative 1, you have here x to the power of negative 3 plus 1 over negative 3 plus 1 plus, second term, 3 x to the power of negative 2 plus 1 over negative 2 plus 1. And of course, you have your minus 5, and the integral of dx is just actually x plus c. It depends on the variable here, so you have x plus c. And again, we will have plus c in this case. So you have 5x plus c, supposedly to be with that. And when you try to multiply that, you will have 5c. But then again, since our arbitrary constant c encompasses all, let's just have that as it is. Okay, So from here, let's now try to simplify the results. So you have here x to the power of -2 over -2. You have here plus, let's have plus still 3 x to the power of -1 over -1 minus 5x plus c. Let's apply the signs, and of course this is 1 over -2 or -1/2. Therefore we will have here -1/2 x to the power of -2. Then you have here negative and positive, so you will have here -3 x to the power of -1 minus 5x plus c. Since we don't like expressions with negative exponents, we can apply here the law of negative exponents. So you have here -1 over 2x squared. If you're not convinced with that, of course, you will have your -1/2 times 1 over x squared using the law of negative exponent, and you have 1 times 1 will still be 1, and you have here 2x squared for your denominator. Now for the next term, -3 over x plus, that's minus 5x plus c. This is now the entire antiderivative of the given rational function, which meets the criteria of simply using the power rule and the first three rules previously discussed. If you're not convinced with this, try to come up with this function and find its derivative with respect to x and see if the result will return to this form. And if it is, then your answer here is correct. Thank you very much for watching. So what are you waiting for? Subscribe now.